Hello and welcome to the webinar on organic blackberry production, tips learned from an ongoing research study by Bernadine Strick, David Bryla, and Luis Valenzuela. My name is Alice Formiga and I'm the webinar coordinator for eOrganic. eOrganic is the organic agriculture community of practice with eExtension. You can find all of our published articles, videos, and our many upcoming and archived webinars on organic farming and research topics on our website at extension.org/organic_production. This presentation is being recorded, and you'll be able to find the recording on our website and on the eOrganic YouTube channel within the coming week. I'd just like to give you a quick rundown on how today's webinar will work. The presentation will last approximately 50 minutes. After that, we'll be asking you 3 quick poll questions, and then we'll have an additional 30 minutes for your questions. If you have a question at any time during the presentation, you can type it into the question box and hit return. If you can't see the question box, just click the small plus sign next to the word question on your control panel, and that will open it up. We'll be reading the questions out loud after the presentation is over, and we'll answer as many as we have time for. Later today, we'll also be sending out a short evaluation survey by email, and we'd very much appreciate it if you could give us your feedback. So we are very excited to be hosting Bernadine Strick, David Bryla, and Luis Valenzuela today for this presentation. Here's a picture. Dr. Bernadine Strick is a professor of horticulture and is the extension berry crop specialist at Oregon State University. She does research on whole plant physiology and production systems of all berry crops. Dr. David Bryla is a research horticulturalist at the USDA ARS Horticultural Crops Research Unit in Corvallis, Oregon. He does research on a variety of small fruit crops, including blueberry, blackberry, raspberry, strawberry, cranberry, and wine grapes. Dr. Luis Valenzuela is a postdoctoral research associate at Oregon State University. He got his PhD in horticulture at Penn State in 2008, and since then he's been working studying the root dynamics of several berry crops in the Pacific Northwest. So with that, I'm going to hand things over to our first presenter, Bernadine Strick.
Hello and welcome everyone. Today we will be presenting research-based information from a larger organic blackberry trial funded by the NIFA OREI program, and the acknowledgement of that grant is at the bottom of this slide. While we are going to focus on a trial in trailing blackberries, we feel that what we've learned should provide useful tips for all blackberry growers. I'm going to start this presentation, and then Drs. David Bryla and Luis Valenzuela will provide information later in the presentation. So what I'd like to do first is acknowledge and introduce the graduates who've been working on this project. First, Renee Harkins. She started her master's in this particular trial and has since graduated. Javier Fernandez Salvador is presently working on a portion of this trial and also doing research on fresh market blackberry production systems, organic also. And Emily Dixon worked on the trial starting last season and will collect another year's data this upcoming season and expects to finish in 2015. And we will be presenting data from each of their studies. What I'd like to do is give an overview of the topics that we're going to cover, and first of all give you an idea of the makeup of this particular experiment, including how the planting was established and the treatments. And in order for you to understand our results, I think it's important that I present information on how trailing blackberries grow and how they're managed. Also then, we'll cover the cultivar and weed management effects of these treatments on yield and growth. Dr. Bryla will talk about the impacts of our treatments on soil and plant nutrition. Well, actually, I'll do that. He'll talk about drip irrigation and fertigation, and then Dr. Valenzuela will talk about soil moisture and root growth. And then we'll finish up with a summary of successes and some challenges. And as mentioned, we will have some poll questions at the end, and we would really appreciate it if you would stay on board and answer those for us. So first, to the objectives of this study, we're looking at the impact of weed management on plant growth and weed pressure and yield, but also on nutrient accumulation and losses. So how much nutrient is removed when we harvest the fruit or when we prune the plant. And this information provides us tools for developing better nutrient management programs. Also, we're looking at the effect of post-harvest irrigation, with or without irrigation, and training time. When are the primocanes trained? Are they trained in August or February? So today, with our limited time, we won't be discussing the results of training time, but we will cover these other aspects. So first, where is this trial located? It's at Oregon State University's North Willamette Research and Extension Center. It's 1 acre in size, and it was in transition from the planting year 2010 until it was certified organic by Oregon Tilth in 2012. So we established tissue cultured plants in May of 2010 at a standard industry spacing of 5 foot in the row by 10 foot between rows. We have a cereal rye common vetch cover crop between the rows that we mow when needed, and it's irrigated using a single lateral drip tube that Dr. Bryla will talk more about. So our treatments are cultivar, Black Diamond, and Marion. These are the two most important processed trailing blackberry cultivars grown in Oregon. They account for most of our 8,000 acres of blackberries here in this state. And then we have 3 weed management treatments. Non-weeded, where the only weed control done was removing weeds around the young tissue cultured plants in the establishment year. Hand weeding, where we hoed 2 or 3 times a year to remove any small weeds that were present. And porous black landscape fabric weed mat, where the only area that really needed weeding was in that planting hole area around the plant. Then we have the 2 irrigation treatments and the 2 training time treatments that I mentioned previously. So here is the planting in the establishment year, which we'll call year 1. This photo was taken in July. These tissue cultured plants were established in May, and this is a pretty standard plant size for our blackberry industry. Some organic growers, instead of planting something this small, might pot it on and let it grow on until it's a little bit bigger before planting. So these plants, the primocanes would grow in the planting year, and here is what this planting looked like at the end of the following winter. We see it had some primocane growth the year before. But what we did was we cut off these primocanes so that starting the second year, you'd only see a crown, and of course, in the soil, there'd be the roots. So we are making the plant, in a sense, start again with new primocane growth. And this is what those primocanes looked like in July of the second year. And these primocanes were trained as they grew, which is pretty standard for our trailing blackberry industry. So then the following winter, at the end of the winter, this is what the planting would look like starting year 3, with the primocanes having been trained onto a standard 2-wire trellis. These would then bloom, and this is in May of our first year of production. And this shows our weed management treatments in that first year of production, 2012. So on the left is the non-weeded. The weeds were allowed to grow. And then right before machine harvest, these were cut off to just above the soil level so that these weeds would not interfere with the machine harvester. In the middle is the hoed treatment. We'll call that bare soil sometimes. And then on the right is the weed mat or porous landscape fabric. So as is pretty typical for our processed blackberry industry, we used an over-the-row freewheeling rotary machine harvester. This one's manufactured and donated to our program by Litow Harvesters, which is based in Oregon, and it's the most common machine harvester used by our processed blackberry industry. So we have to keep the weeds from getting too tall so that they don't interfere with the catcher plates of the machine harvester. We want those to fit tightly around the base of the plant to improve machine harvest efficiency. We harvested twice a week, which is pretty standard, and only the ripe fruit fall onto the catcher plates and then are brought to the top of the machine where we have a short sorting belt to remove any obviously cull fruit or unmarketable fruit. After harvest is done, the floricanes die, as is standard in these floricane fruiting blackberries, and then these are removed. We call that pruning or caning out, and we weighed the material that was removed from the plot, and this is a way to measure canopy size as affected by the different treatments. So once the floricanes are removed, the primicanes can be trained, and these trailing blackberries grow very long primicanes, 15 to 20 feet long. They're typically divided into 2 bundles per plant, and half is trained in each direction on a 2-wire trellis. And this shows Emily and a co-worker training canes. So our 2 training treatments are either August training, which is shown on the left. The plant then continues to grow a bit on the trellis canopy. And then on the right, the other option is leaving the primicanes on the ground all winter long until late February when they're trained up. So this shows the planting after training in August, with the August trained up on the wire and the February trained primicanes still remaining on the ground, and they'll be trained later in the winter. We do want to give you an idea of how these plants or treatments were fertilized. All of the treatments were fertilized exactly the same way. This is not a fertilizer study. So the table shows 2 different products being applied in 2010. A Nutri-Rich pelletized poultry litter was incorporated in the soil right where the plant was going to be established prior to planting, and then a Fish Agra liquid fertilizer was applied by hand around the plants for a total of about 50 pounds of nitrogen applied in that establishment year. In year 2 and in year 3, the first fruiting season, we fertigated True 402 for a total rate of nitrogen of about 50 pounds, 47. And potassium and sodium were also high in that liquid fish product. And then in 2013, we increased the nitrogen rate applied to almost 65 pounds of nitrogen per acre using 2 different products that were fertigated. Also, based on tissue and soil analysis, we decided to add a granular boron and a lime to the soil surface as a broadcast band in late winter 2013, prior to our second fruiting season. And because we have a weed mat that could not be removed or opened, we broadcast the product over top of the weed mat. And other research done in Texas has shown that weed mat is porous enough for this to be an effective treatment. So first, I would like to talk about the cultivar effects on yield. This graph shows, or this slide shows, 2 different ways to present the data. So first of all, on the left, we have a yield over time showing the different machine harvest dates and how the cultivars differed in their harvest over time. So it's clear from the top graph on the left that Marion, which is the purple line, has a harvest that started later and finished sooner than Black Diamond, and also has a more concentrated harvest period. The bottom graph shows that yield patterns can change from year to year, and this is not unusual when we have different weather patterns. On the right is the total yield over the season, and in both years Black Diamond had a higher yield than Marion, which we would expect based on industry experience. The yield for 2012 averaged 6 tons an acre for Black Diamond and 5 tons an acre for Marion, and of course that's machine harvested yield, but that is averaged over the best and the worst weed management treatments. And these yields would be expected, are quite similar to what we would expect in a conventional system, I think. In 2013, the yields declined, and this could be for several reasons. But one of those reasons might be related to competition between primocanes and floricanes. So on the lower left, you can see the machine harvest of a Marion blackberry plot that is weedy with no weed control. And those floricanes that are being harvested, when they were primocanes the year before, they grew without any competition from floricanes. And we often get much more growth then and bigger canopies. Whereas the plot on the right in 2013 is a weeded plot or a bare soil plot, and you can see the canopy is considerably lighter. But those floricanes the year before were competing when they were primocanes with a pretty big floricane yield. And so we commonly see these fluctuations in yield between cropping and non-cropping years. So this graph shows, or slide shows, the different weed management treatments, just to give you an idea of differences in canopy size and differences in color between these varieties. In 2013 was year 4. It was the second year of production, and this shows Black Diamond right before harvest with the different weed management treatments. And looking at the effects of weed management on yield, they were quite dramatic. So let's look at the left first. The green line are the non-weeded plots, and it's clear in both years that yield on every harvest date was much lower in these plots than in plots where we controlled weeds. What was also interesting is that the weed mat plots had a higher yield than the bare soil plots in both years, but particularly in 2012. So if we look at the total seasonal yield on the right, you can see that weed mat at 7 tons an acre, averaged over the two different varieties, was almost double the yield in the non-weeded plots. And even though yield declined in 2013, we still had a higher yield in weed mat than in non-weeded and bare soil compared to non-weeded. Why was this? Well, there are a few reasons why we saw differences in yield among these weed management treatments. First of all, cane number per plant. When primocanes grew in the presence of weeds, there were fewer canes per plant than in the weed control plots. And this then is reflected in a lower floricane number per plot the following year. Also, when we evaluate canopy size by pruning, Marion, we know, is more vigorous than Black Diamond, so that is not a surprise to see more prunings in Marion than in Black Diamond. But what is interesting is how weedy plots were so much lower in canopy size, but also weed mat plots had a larger canopy than those in bare soil. And this is an interesting response that we plan to look at further, that difference between weed mat and no weed mat. Finally, one of the reasons for the yield difference also is just that berry weight was less in weedy plots than in plots where we controlled weeds. So it's clear when we look at commercial fields and we see weed presence, like in this commercial trailing blackberry field, that I would be concerned that the presence of weeds like this in the row would be reducing primocane growth as well as potentially reducing floricane yield. There are different philosophies and ways to manage weeds, and in this commercial organic Chester blackberry field, I think it's clear based on our knowledge of Chester that this is a low cane number per plant, but this particular grower feels that he gets quite good fruit quality, and we always have to outweigh the costs of weed management with potential benefits. This grower uses a mow and blow system, which is another option. This particular organic grower, also of Chester, is managing weeds in the row. And finally, this grower is using landscape fabric to control weeds or manage weeds in this triple crown semi-erect blackberry field. The question that I often get is, what are the costs of these of weed mat, and is it economical? So this particular slide shows our estimate of the costs of the 3 different weed management strategy during the establishment years in dollars per acre. So we have our 3 weed management treatments on the left, and then the next column is the materials costs. And of course, the only strategy that has any costs would be the weed mat. This materials and install cost includes putting the weed mat in the field, cutting holes into the weed mat, and then the amortized cost of the weed mat. So if we estimate that the weed mat would last 5 years, we divide the total cost of the weed mat into a per year cost, and here we are only including the first 3 years for that cost. Then when we look at hand weeding costs, this is in dollars per acre with a base of $15 per hour for labor, which would include all labor costs. You can see that the only time we had to control weeds in the non-weeded was there around those young plants in year 1. The cost for hoeing in the hand-weeded treatment increased from year 1 through 3 because weed pressure increased. And the costs for managing weeds in the weed mat are pretty stable because we're only looking at that around the plant hole. So that gives us a total cost for these weed strategies in dollars per acre. And then if we look at gross returns, we base this on the yield, which differed for these 3 treatments, and then an estimated cost for processed organic machine harvested blackberry fruit of 95 cents a pound. That gives us the gross returns. So subtracting the costs from the gross returns, we get the final column on the right, which is our net income in dollars per acre. This isn't grower return per acre because it doesn't include all the other management costs, but we did assume that all those other costs were standard or uniform across these 3 weed management treatments. So it's clear that weed mat paid for itself very quickly during these establishment years. It's almost double the non-weeded treatment in terms of net income return, and even higher than the hoed treatment. So what impacts do these weed management treatments have on soil and plant or fruit nutrients? So these graphs show our soil sample findings or results for the 3 years we've collected samples so far, 2011, 12, and 13. Which are the different bar colors, and as affected by the weed management treatment. So again, we're averaging over our other treatments like cultivar. We're showing pH and soil organic matter here, and what we found, particularly in 2013 in the autumn when we sampled, is that soil pH was significantly higher under weed mat plots than under the other treatments. And we certainly did see an increase in pH in many of our treatments, and remember we did apply lime, so we might be seeing a relatively rapid response there, but we commonly see pH higher under weed mat than under other mulches. In organic matter, we've seen pretty much an increase in all of our treatments in organic matter, and this is a little surprising under weed mat, because work that others have done in tree fruit and work that we've done in organic blackberry shows that organic matter declines when you use plastic or weed mat, mainly because soil temperature increases and you get increased mineralization of organic matter. So why are we seeing an increase in this blackberry trial? It could be because we don't see an increase in temperature under the weed mat in these trailing blackberries. And one of the reasons for that could be that the primicanes are shading the weed mat. And secondly, when we've been sampling for soil in the autumn of each of these years, these blackberry plants have been growing from small tissue cultured plants to very large plants, and we expect with quite large root systems. And so it's very possible that we are not just sampling soil when we're taking a core, that there are fine blackberry roots in there, and in the weedy plot, fine weed roots, and those are increasing soil organic matter. When we look at some of the soil nutrients, and again, I don't have time to show everything, but when we look at soil potassium and soil calcium, we are seeing higher values under weed mat than under the other weed management treatments. And particularly, and that might be related to less leaching through the winter months when we have a lot of rain. And soil potassium is declining, has declined over the 3 years that we've been sampling. And this is possibly a reflection of our results showing that blackberries have a relatively high demand for potassium. And finally, soil nitrate has been quite variable. It was less in 2012 than it was in 11 and 2013, but even though we are seeing these differences, these numbers are not very high. Moving to the fruit, this table is showing the results that we obtained when we sent fruit in for nutrient analysis. It's no different than sending in a leaf to look at plant nutrient status. We're sending in fruit. Then we get data back on what is the percent moisture content of that fruit, how much of it is dry weight, and then what is the macro and micronutrient content of the fruit. And the reason we want to do this is because no one in blackberry has looked at the fruit makeup of blackberry. How much nutrient are you removing when you're harvesting the yield? So what we're showing here is the nutrient content now in pounds per ton, per fresh ton harvested. So if we look at nitrogen, we are seeing a cultivar effect in many of these nutrients. And we have a range. For example, black diamond is 2.9 to 4.5 pounds of nitrogen per ton of fruit harvested. So this is telling us that if, for example, you were to harvest 5 tons of fruit per acre, your nitrogen removal in that fruit would range from about 15 pounds of nitrogen per acre to about 20 pounds of or 25, excuse me, pounds of nitrogen per acre. So this is a really interesting tool. And if we look at the macronutrients and the micronutrients, really the only other nutrient that's significantly removed in fruit when we harvest is potassium at almost the same amount as nitrogen. Weed management treatments affected many nutrients that were removed in the fruit, particularly the weedy plots, those that we didn't remove weeds in, had a lower fruit nitrogen and potassium content and many other nutrients. We did look at fruit quality and some aspects of fruit quality, and what this is showing you are differences in Brix or percent soluble solids. What we found was that plants that were growing in the presence of weeds produced berries that had a higher percent soluble solids content than plants that were growing with weed control. But what's important to understand is that when we measure this measurement of sugar, is that it's a percent soluble solids, not a total quantity of sugars that are in the fruit. So percent moisture content of the berry becomes very important when you're measuring percent soluble solids. And what's very interesting is that when we look at the impact of weed management on percent moisture content of the berries, fruit that came from plants without any weed control had a lower percent moisture content than fruit that came from plants with weed control. This then really makes us think about, wow, what impact are these different weed management treatments having on plant and soil moisture content and the impact that that has on production. And so with that said, I'd like to introduce Dr. David Bryla, who's going to speak about irrigation management.
Thanks, Bernadine. Hello, everybody. So I'm going to talk about what work we've been doing with regards to irrigation in this project. first question that I like to answer is, why is irrigation important? If you're not from the Pacific Northwest, I know a lot of people think we get a lot of rain in the Pacific Northwest, and indeed we do. We do get a lot of rain, and there are a lot of days that we don't see much sunshine. But the reality is, in the summertime, we get very little rain. Most of our rainfall is in the wintertime, and as well as the fall and the spring. Our irrigation season typically runs from about the beginning of May to the end of September. So we do need to irrigate. If we do not irrigate, we won't get the production that we need for commercially. So typically, blackberries are irrigated in Oregon by one of two methods, either using sprinklers or with drip. But for organic production, we definitely recommend drip irrigation for two reasons. One is, of course, drip is going to be more efficient in terms of how much water you need. Obviously, you're not going to be applying the water between the rows. All that water is going to go directly to the plant, so you need a lot less water to get the same amount of production. The other reason is that if you use sprinklers, you're going to get a lot more weed growth than you would with drip irrigation. So what I'd like to talk about now is how we installed our drip system,
Unmuted,
and how much water we applied over the growing season. So
I'll give you back the control of the slide there. I think something happened here, so let me just try and give it back to you. Okay, yeah, try and just click on the screen once now and see if you can advance. There you go. Oh, went too far.
Okay, there we go.
All right, you got it now.
Okay, so as Bernadine mentioned, we had three different treatments. We had
muted,
non-weeded plots, and we had weed mat plots. And what we did is we used a single line of drip for each of these plots. So in our hand-weeded or non-weeded plots, we hung the drip lines from a lateral about a foot off the soil surface. That basically keeps it out of the way for hand weeding and so forth, and that way it's not a problem. Now for the weed mat, even though it is a porous landscape fabric, the water does tend to run off of it. So what we did there is we installed the drip line underneath the weed mat. So basically we had the drip line and covered it up with the weed mat, and that worked out very well. The spacing that we had was about 2 feet. Well, was 2 feet between emitters. We used inline emitters. Now, the actual spacing that you might use on your farm could differ depending on your soil type. For example, if you had a sandier soil, you might want to have a closer emitter spacing. Our soil here is a silty clay loam, so the water moved laterally quite well. The flow rate we used was about a ½ gallon per hour emitters, and these were self-cleaning pressure compensating emitters. If you have problems with water quality, you may want to use a higher rate emitter, something like a 1 gallon per hour emitter, and then you'll have less issues with plugging. We established the planting using the drip. We did not use sprinklers to establish the planting, but what we did to make sure the plants had plenty of water during this period, the plants, as you can see in this picture, are quite small and about the same size of all the grass growing around it. But if we irrigate it in short, frequent pulses of 15 to 30 minutes 4 times a day, we found that we were able to maintain basically a uniform water content from one plant to the next, and we never developed any water stress in the plants. So they established quite nicely this way. And on the bottom corner, you could see an example of a young plant with the weed mat. We also injected our fertilizer through our drip system. This is called fertigation. But the first year, we felt that because the emitters may not have been very close to the plant, we did apply it by hand around the plants, and then switched over fertigation the following years. We used a fish emulsion, fish hydrolyzate, to inject through the drip system. We had a question, would this cause problem with plugging? Obviously, if you're using conventional fertilizers, they are quite soluble and you don't have to worry about them plugging necessarily, but as you can see in this photo of the fish fertilizer, it's quite thick, so we didn't know if the sediments in this would plug the emitter. So we had tested that, and we did see some plugging each year, about 10% plugging per year on average. However, we also, to reduce that, we would flush the drip lines. So by opening it up the end of your drip lines and flushing it after you fertigate for the season, That helps wash the sediments out of the drip line and will reduce the amount of plugging that you get. We tried two different types of injectors. Initially, we tried a water-driven injector. We chose that for two reasons. One, it's less expensive than an electric type injector, and also it doesn't require electricity. But what we found with this particular type of injector, that because the fish was so heavy, it would wear out the injector very quickly. So we switched over to electric dosing pump, and that's working quite well for us at the moment. So next, what I'd like to do is take you through irrigation of the established planting all the way from bud break to post-harvest. So if we start in the left-hand corner, upper left-hand corner, at bud break to flowering, typically that occurs between the beginning of May to early June in Oregon. And during that period, we get about 3 to 6 inches of rainfall. Our low temperatures are about 50 degrees Fahrenheit, and our highs are average about 7 degrees Fahrenheit. During this time, the plants are using about 2 to 6 gallons of water per day. So what we do during this period is we irrigate as needed. Sometimes we might get rain, we don't need the irrigation. Other times it might be drier. However, once we start getting into the fruit ripening period, which runs from June to early July, the rain starts to diminish. We get about 1 to 1.5 inches of rainfall during that period. The temperatures rise with high temperatures up to 78 degrees Fahrenheit on average, and the plants are now using 6 to 8 gallons per day. So at this point, what we do is we switch to irrigating 3 to 4 days per week. So pretty much every other day we apply irrigation, and we base it on the weather conditions. So the hotter it is, the more water we apply. The cooler it is, the less water we apply. And then we get into the harvest season, which is early July to early August. And this is typically the warmest period here in Oregon. We usually don't get any rain during this time. Our average high temperature is about 85 degrees Fahrenheit, although we can get into the 100-degree weather during this period. Plants are using about 6 to 9 gallons of water per day. And what we find during this period, when the fruit basically are going through their final stages of ripening and we're harvesting, is that it's best to irrigate daily. The plants require the most water during the harvest period, so keeping them well irrigated during this time will actually increase the size of the fruit and increase the yields. And then the final period is post-harvest, which runs from August to the end of September. This period is also dry. We typically get less than an inch of rain, and most of that rain will happen in late September. The temperatures are about the same as they were during the harvest period, with average highs of about 85 degrees Fahrenheit. And the plants start to use less water. They're using about 4 to 8 gallons of water a day. And at this point, what we do is we switch back to irrigating to every other day, so 3 to 4 days per week. One thing that we found that was very interesting is that we compared how much water we're using with the hand-weeded plots versus the weed mat plots, and we found the plants actually used more water or required more water with weed mat than with the hand weeding. So why is that happening? Well, a couple ideas that we have is that with the weed mat, the plants are growing a little bit bigger, so you have a larger canopy. So if you have more leaves, the plants are going to use more water. It's also possible that the temperature above the weed mat is warmer than above the soil surface, and if you have a higher temperature, plants will tend to use more water. So what we're finding is that with weed mat, we get about 10 to 20% more water needed during that time. So we had to apply 10 to 20% more irrigation than with those plots that were hand weeded. Another question we had is, do you need to irrigate after harvest? Some growers in Oregon will turn off their irrigation after harvest in an effort to try to conserve water. So the obvious advantage of turning that irrigation off after harvest is it does save water. It'll also reduce weed growth, because if you're not giving water to the weeds, they're not going to grow. But the idea is it can help the plants harden off for the winter time. So if you stress the plants after harvest, they'll start to shut down, and then when winter comes, they'll be able to better tolerate winter conditions. So we wanted to look at that. So what happens if you turn that irrigation after harvest? Will that help? Now, some other disadvantages, perhaps, of turning the irrigation off after harvest is that you're going to have less plant growth, less primocane growth after harvest. You'll have fewer flower buds, which then, of course, is going to lead to less yields. So we had our treatments where we either continue to irrigate after harvest. So after harvest was finished in August, we would irrigate till the end of September versus shutting that irrigation off during that time. And what we found was, if you look at the top table, the floricane traits, we have our post-harvest irrigation treatment on top, and then our no post-harvest irrigation treatment. If we look at the length of the floricanes, we saw no difference in the lengths with post-harvest and no post-harvest irrigation. The number of nodes were significantly higher with post-harvest irrigation, and bud break was less with post-harvest irrigation. However, the number of flowers per lateral was the same between the two treatments. Now, if we look at fruit production, now this is only 1 year data, but what we found is no difference in yield at this point, no difference in berry size at this point, and no difference in the sugar or the bricks of the fruit. So, do we need irrigation after harvest? Well, we still need to determine that, but how much water did we save? Well, in this particular study, we saved 67,000 gallons per acre. It could be much higher than that. Some growers will apply more water than we actually did. We were basically trying to limit the water as much as possible to increase our water use efficiency, but it's still, as you can see, this is a substantial amount of water that we save by turning off the irrigation after harvest. So the question is, can we do this every year? So now Dr. Luis Valenzuela will talk about what happens below ground when we turn off this irrigation.
Oh, thanks, Dave. Hello, everybody. What I'm going to talk about is the work that we're doing looking at blackberry root development, water uptake, and soil water availability. So I want to start reminding everybody that plant water use starts below ground, and well, below ground is where roots are taking water and nutrients. And I want to I already did that. It's not moving.
Unmuted. Hi, Luis. Hold on one moment. I'm trying to get you the slide control.
Yeah.
It's something it has you logged in under a different name, so I'm trying to get it fixed up here for you. Okay. In the meantime, I'll just advance the slides for you.
Okay. So I'm just gonna, sorry about that. I'm just gonna take a short moment, and have a little introduction into root systems. And this is my first take-home message for you. Not all the roots are created equal. Not just because it looks like a root, it means that that root can have the ability to absorb water and nutrients. Water and nutrients absorption occurs mainly by the fine roots, and these roots are usually located at the end of the branches of the root system. Also, these roots form the section of the root system that is very dynamic. And what do I mean about being very dynamic is, for example, we know that a lot of fruit crops produce new roots, new fine roots every spring. Initially, these new roots are very efficient taking water and nutrients. Then over time, obviously, that when they get old, that ability decreases. And then some die, and some of the conditions are, if the conditions are good in the soil, the plant can replace them. And this is a pattern that it's happening continuously in the soil during the season. So if we want to understand how irrigation and therefore soil moisture availability affects plant water uptake, well, knowing the location of these fine roots in the soil, and the distribution is quite important. To finish this little introduction, I want to show you these slides, the one that we're looking at. And pretty much what it's saying is that the root system in plant is very flexible. And this is a very general plant response pattern. When there is a lack of water nutrients, usually the plants have the ability to grow bigger or deeper root systems. And so they can look for that lack of soil moisture in the surface and look for the resources that they need. I'm just going to move into the next slide. So after that introduction into root systems, let's talk about what we're doing with Blackberry root systems. So what we're looking at the effects of the post-harvest irrigation and non-post-harvest irrigation on two weed management systems and the fine distribution and soil water availability. So what we have here is the top picture is the hand weeding plot with post-harvest irrigation during 2012. In which irrigation continued until the first week of October. On the bottom picture, we have hand weeding plots with non-post-harvest irrigation, and where irrigation stopped in August 8, just right after the end of the harvest. You can see that the pictures were taken in September 21st, and that fine silty clay loam soil looks very dry by then, at least in the surface. One thing that I want to mention is that these soils in the Willamette Valley are very deep, and the hard pan can be as deep as 30 feet. Moving on to the next slides, I want to show you the weed mat plots on top with the post-harvest irrigation, and on the bottom, the weed mat plots with no post-harvest irrigation. Just to remind you, you're seeing there an irrigation line on hanging on the wire. That's not the actual irrigation line for the weed mat plots. For the weed mat plots, the irrigation line, it's located under the weed mat plot. Let's move into the next slide. So how are we doing can you go back one, please? How are we doing the evaluation of this root development and distribution? Basically, what we're using root observation tubes, and these are 6 feet long clear plastic tubes installed in plants on weed mat plots and hand weeded plots, also in the two irrigation regimes. They were installed in the end of 2010 across all reps, and we have a total of 80 tubes. Can we move to the next one? We use a special camera that is fixed on top of the tube and goes inside the tube and is connected to a laptop computer. Then in that laptop computer, we can, using the camera, we can take digital photos of the roots that are growing outside the tubes. The tubes remain closed with a rubber stopper, and you can see those PVC caps that protect the tube and prevent the light to going inside the tubes. So far, we do this image photo collection every 2 weeks during the growing season and once a month during the winter time. We can move to the next one. So far, we have collected almost 200,000 photos from this study, and we're still counting. So once we have all these photos, what we do is we took them into a computer, and then using a specialized software, we can keep records of single roots, where the birthday of single roots, the coloration, diameter, we can measure diameter, we can measure the length. We also keep a record of when the roots die. And all this information together give us an idea when these fine roots are present in the soil during the growing season. And also, since the tubes are 6 feet long, we can also have an idea of the distribution within the soil profile. We can move to the next one. And what we're doing with soil moisture availability, we're monitoring soil moisture using a neutron probe. And as I mentioned before, soil spheres are very deep. We're using a 6 feet long access tube for the neutron probe. And that tube is located in the center of the plots, and we're doing these measurements every week during the growing season at 7 different soil depths. We can move on. So let's look at some of the preliminary data that we have. Let me explain the graphs first. On the y-axis, we have soil moisture content, and the x-axis we have, this is data from 2012. And then you're going to have on the left, you're going to have Black Diamond, and the right, you're going to have Marion. Then every plot has two lines, a blue one and a yellow one. The blue one is the post-harvest irrigation. The yellow one is non-post-harvest irrigation. Other information that you're going to see there is a red triangle. That's the date when we stop irrigation. And on the right, you're going to see the different soil depths that we were monitoring this soil moisture. So what I want you to look at in these graphs is at the time when the two lines separate from each other, when the yellow was becoming drier, and also at the magnitude of separation. So if you look at this, at least at this soil depth from soil surface to 12 inches depth, we can see that at least in Black Diamond, the separate, well, at least for the both, for the bud cultivar, the separation occurred at the same time, but for Black Diamond, the separation was larger. So this is suggesting, at least at this soil depth, that Black Diamond was taking up water faster than Marion. Now, our preliminary root data in 2012, and we go to the next one, shows that for Black Diamond, we have 15% fewer roots with no post-harvest irrigation, and for Marion was only 3% fewer roots with no post-harvest irrigation. When we move to the 2013 data, go on. That's where big, can you go back, please? We see some of the significant differences. 15% fewer roots with no post-harvest irrigation on Black Diamond, while on Marion, instead of seeing less roots, fewer roots, we're seeing more roots, 21% more roots with not post-harvest irrigation. In the case of Marion, it looks like, at least for 2013, 2012, at this soil depth is following the same pattern as trying to put more roots to try to look for that lack of soil moisture. We can go to the next plot, please. So once we move to the 12 to 24 inches, the separation of the two lines occurred 2 weeks earlier in Black Diamond. You can see that on the top. And even if we move to the 24 to 36 inches, the separation occurred a month earlier on Black Diamond. So all this is at least suggesting that Black Diamond is at this soil depth is utilizing or is taking water much faster than what is doing Marion. When we move into the root data, we can see that on the 12 to 24 inches, can we go one? Yes. We see 70% fewer roots with non-post-harvest irrigation on Black Diamond in 2012, and at 24 to 36 inches at 20% fewer roots with non-post-harvest irrigation. Again, in 2012, Marion is doing the opposite. We have 7% more roots with non-post-harvest irrigation and 9% more roots with non-post-harvest irrigation. Once we look at the 2013 data, and we move one more, we see that still Black Diamond, we're seeing the same patterns, fewer roots with non-post-harvest irrigation, and at least for 2013 data, Marion, it looks like it's following now the same pattern as Black Diamond, but the numbers still are not as high as in Black Diamond. So let me say that the explanation for seeing fewer roots in non-post-harvest irrigated plots is not clear yet if this is because of higher root mortality or because we have less roots produced. And I'm sure we're gonna be able to answer this better once we finish all the analysis of the photos that we're taking. We can move on. So once we move to the soil depth from 36 inches to the 72 inches soil depth, we can see that there is not a lot of differences between the lines, suggesting that either the cultivars have the same similar roots taking up water here, or maybe there is not a lot of roots from both cultivars, utilizing the water at the soil level. We can move on. So as a summary, I just want to say that Black Diamond appears to use water faster than Marion. This is occurring mainly at soil depth of 12 to 36 inches. Deeper than that, the differences in soil water availability between the cultivars and irrigation treatments are not apparent, very significant. The lack of irrigation the lack of post-harvest irrigation seems to have a great impact on Black Diamond root systems. So we need to consider this if we want to think about the sustainability of Black Diamond plantings. And Marion seems to be more adapted to dry soil conditions. And well, the question is, how does this ultimately impact the way that we irrigated plants? And that's a question that probably Dave can answer for us. Thank you.
So, thank you, Luis. So what I'd like to do now is just give you a summary of some key we have for successful irrigation in organic blackberries. So we find that all you need is one drip line per row. Adding a second drip line is not needed. We recommend using self-cleaning, pressure compensating emitters. That'll reduce plugging and adjust for any kind of variation in elevation so that you don't have more flow from one emitter and less from another to get more uniform applications of water. We find that we can establish the planting with drip, and that we don't need sprinklers to do that. We suggest increasing irrigation during fruit ripening. We irrigate every day during that period. Otherwise, if we don't, we do find that the plants become stressed and we get lower yields. And if you're using weed mat, apply a little bit extra water. We found that the plants require about 10 to 20% more water with weed mat than they do with hand weeding. You can inject the organic fertilizers through the drip systems. We recommend an electric dosing pump rather than a water-driven pump because they're more robust and can do a better job. But you do want to flush out the lines at least once a year following the fertigation season so that you don't have the sediments in the line plugging your emitters. So our big question now is, can we irrigate, or do we need to irrigate after harvest, or can we shut off our irrigation after harvest? As I showed, we did not get any reductions in yield, but that's only after 1 year. As Luis clearly showed, we are seeing some effects of not irrigating after harvest on the root system. For example, in Black Diamond, we're seeing considerably less roots without irrigation after harvest than with. So what impact will that have on the plant as it goes through its life, and will that eventually start causing problems and yield reductions?
Thank you, Dave. So in addition to the challenge of the long-term impacts of irrigation, we've had some other challenges related to this particular project. Alice, can you give me control,
Yeah,
please?
you should have the control now. Just click on the screen there. If it doesn't, yeah, you got it. Okay, let's try it one more time. Okay, try it now. Yep, there we go.
There we go. So our biggest challenges have been related to insects, and just any organic grower would face. We have these unforeseen problems. So the first problem that I want to mention is that when we were training in August of 2013, we noticed primicanes flagging in the plots, and that's shown on the picture on the left. And when we investigated this further, we noticed larvae inside of these primicanes. And these are larvae from the raspberry crown borer, which is a problem in all of our raspberry and blackberry fields, but populations vary from year to year. And what is frustrating about this pest is that really the only organic control method that is mentioned in the literature relates to roguing out infested plants. And speaking personally here, I do not think that's a very practical method of control. So what we would like to do is find some control methods that might work for this pest. What was interesting is that when we evaluated how many plants were infested in 2013, in August at least, this insect appeared to have a preference for black diamond over Marion, and black diamond's thornless with lush green leaves, and Marion is thorny with a lighter colored leaf, and that may be one of the reasons, but we will need to figure out a good way to manage this pest in this organic trial. Secondly, spotted wing Drosophila is a very important insect pest in berry crop production in this region as well as many other regions in the U.S. And just like any organic grower, we're needing to find control methods that will help prevent the larvae from being in the fruit. So the only method of control that we have found effective that is OMRI approved is Entrust, a spinosad. But we are concerned that with only one method of control that the insect might develop resistance. So this is certainly something that we and many growers are concerned about. So in addition to the summaries that Dr. Bryla and Valenzuela provided, we have learned that weeds do compete with establishing and mature blackberries. They reduce growth and reduce yield. And weed mat has been a very effective management tools for us, and it's been cost effective. And this is something that looks very promising for this type of blackberry that does not produce primicanes from the roots. We are learning more about the treatment effects on nutrient losses when we prune and when we harvest fruit, and we're going to use this information to develop more fine-tuned nutrient management programs for blackberries. And finally, while our yields have been similar, perhaps slightly lower than they would be in a conventional production system, we do need to look at the long-term effects of weed mat, which is our most effective method of weed control, on soil properties and nutrient management. I do want to acknowledge the many people that are involved in this particular portion of the larger organic production grant. In particular, my research assistants that have worked or are still working on this particular trial, Amanda Vance, Gil Buller, and Emily Vollmer. The technician working with Dr. Bryla, Amber Shireman, and the graduate students that I introduced earlier, and then our very supportive grower advisory group that continually provide advice on this trial, as well as others we're working on, and the funding that I mentioned earlier. So with that said, I would really appreciate it if you would please
Unmuted.
respond to the poll questions that we have prior to us handling any questions that you might have. Thank you.
Hi, everyone. We're just going to launch a couple of quick polls for any of the growers in the audience. These will just be up on the screen for maybe 20 seconds maximum or so. And the first ask what best describes you, and answer only if you are a grower. We'll broadcast the result in a second. An existing organic blackberry grower, conventional blackberry grower, conventional grower considering organic blackberry farming, or organic grower considering blackberry production. So we'll just leave that up for a second or two, and then we will close this and share the results. So we have 43% existing blackberry growers, 7% conventional blackberry growers, 15% conventional considering organic, and 35% organic grower considering blackberry production. So we'll move on to the second one, and that is here we go. If you are a blackberry grower, what do you think is the greatest challenge to organic blackberry production? You may think all of these are challenges, but if you could select one: weed, disease, insect, or nutrition management. We'll have those up for another couple seconds. Thank you for voting here. Okay, and the results say that's pretty well distributed, but insect manager seems to be the winner here with 40%. And the 23% weeds, 28% disease, and 10% nutrition management. Okay, and last one. Let's see, how are you applying fertilizer to your blackberry field? By hand, granular or liquid application by machine, fertigation, none, using only composted materials or mow and blow, or a combination of the above. So this was the last one, and after this, we will share the results here. Okay, the clear majority is by hand, then a combination, then none, using composted materials or mow and blow, fertigation, and 0, say granular or liquid application by machine. Okay, well, thank you for filling those out. And for those of you who missed the beginning of the presentation, you can type in questions by just typing into the question box and hitting return, and we'll answer as many of them as we can for the next 25 or 30 minutes or so. And I just wanted to mention also that we have a PDF handout of the slides from this presentation, so if there's something that you missed and would like to see again, or if you'd like to share it, you can find a PDF of the slides at the second link here on your screen, and we'll also be posting the recording at the same place within the coming week. And you can find all the other eOrganic webinars at the first link on your screen. And if there's a question that we didn't answer or that you think of after the webinar, please feel free to use the e-extension Ask an Expert service, and we will try to get you an answer. So with that, let's open it up to questions. And I know we've been getting questions during the webinar. Okay, yeah, for the spotted wing Drosophila, you mentioned the way that you use it with that OMRI approved product, but somebody was wondering whether netting would work to control spotted wing Drosophila, and if so, what kind and where might you get some? Everyone needs
Alice,
to
I'll
unmute.
take that question.
Okay. Mm-hmm.
Netting can be used to prevent spotted wing Drosophila adults from reaching a fruiting crop after there's some color on the fruit, but it's not considered to be economical or practical for commercial scale production systems, simply because it would be really difficult to net such that you could have picking machines or hand pickers under a net and still provide exclusion for insects not to be able to get in. It is an approved and recommended home garden tool, and for any information on spotted wing Drosophila, including all the control options for organic as well as conventional, home as well as commercial, the website spottedwing.org provides all the latest information on this pest.
Okay, great, thanks. And we also did have a webinar on organic spotted wing Drosophila management strategy, so you can find that at the first link on our screen in our archive. And someone had asked a question during the webinar about what kind of weed mat was used, and so Bernadine had responded that the kind that was used was 10 Kate Protective Fabrics weed mat, which has a water flow of 7 liters per, well, let's see, 7
per hour per
square meter, and it's held by landscape pins on the edges, and the plant holes cut were about 20 by 20 centimeters. Okay, so when using weed mat, would you recommend the zipper method or just a solid piece of cloth? I'm not sure exactly what that means, but maybe you do.
That's a good question. It sounds like this is an individual who's heard me speak about using weed mat before. We commonly recommend a zippered weed mat, which is 2 pieces of landscape fabric that run down the length of the row, and one piece would overlap with another piece and be held in place by some kind of staples. We learned this method from a commercial organic grower ourselves, and we have used it very effectively in our organic, certified organic blueberry research trial. The reason that we do not yet have a zippered system is because we started with a solid piece, and when that weed mat gets to the point where it needs replacing, then we would be replacing it with 2 pieces, which is all you could do in an established planting. Now, with that said, we could have started with a zippered system from the get-go. We just didn't do that.
Okay. Did you measure the soil temperatures to compare the impacts of weed mat with non-weed and hand weeding? I know you mentioned the soil temperature was higher under the. Mhm.
Yeah, we did measure the soil temperature. We were measuring that at a depth of about 2 inches below the soil surface. And while I did mention that weed mat has increased soil temperature in another trial that we're looking at, organic blueberries, where the plants are grown on raised beds, and I think the sun strikes the weed mat more and increases soil temperature by about 5 degrees Celsius. Sorry, I don't know that off the top of my head in Fahrenheit. And in what we're finding in contrast in the organic Blackberry trial, where its flat ground system, is that we are not seeing much of an effect, if any, of weed mat compared to bare soil, compared to weedy plots on soil temperature, interestingly enough. And we think that might be because in this crop, especially in trailing blackberries, the primocanes might be shading the weed mat and preventing the sun from striking it as much.
Okay. Did you mention did you measure anything released by the plastic weed mat? Someone had commented that plastic weed mats release plasticizers, for example, phthalates.
We are not measuring that, and I'm not aware of this product, that this product would release anything.
Okay. What was the daily water demand of the new and mature plants again, if you could repeat that, and the size of the emitter used?
We used half gallon per hour emitters spaced every 2 feet in the drip line. And the irrigation, we typically applied anywhere from 90 minutes to an hour, 3 to 4 times a week prior to the harvest season. Then once we got into harvest, we increased that to daily irrigation. And then after harvest, we then went back to irrigating every other day.
Okay, thanks. In high iron water areas, what recommendations might you have for keeping the emitters open?
That's a very good question. We do have iron bacteria, or high iron, and which then results in iron bacteria, and it's actually these bacteria that can plug the emitters. So under those situations, one thing you're going to want to do is have a good filtration system first off, so that you could filter out as much of these bacteria as possible. The other thing you can do is you can use large emitters, and that's why I say if you have poor water quality, something like a lot of iron in your water, you probably want to go with the 1 gallon per hour emitters. And we do find at our station, even though that the iron's pretty high, when we have emitters in this size, we do see substantially less plugging.
Okay, thank you. Is fish emulsion the best nutrient management method you found, or have you studied other nutrient sources like rotted cow manure?
Do you want to take that one, Bernadine?
I can start with it, Dave. Okay, in this particular larger organic trial, the graduate student I introduced earlier, Javier Fernandez Salvador, as part of this larger grant, he is looking at different sources of fertilizer, organic fertilizers for blackberries, both in processed blackberries, where he's comparing 2 liquid products that can be fertigated, one that's more based on a corn steep liquor, and another that's sort of a fish and molasses blend. And then in a fresh market blackberry trial, he's comparing or has compared composted pelletized chicken with a fish emulsion similar to what we're using in what we described in this particular trial, as well as a soybean meal. And what he's basically found so far is that there's very little difference between these various products on plant performance yield and quality. It's not different than what we would expect to see with conventional fertilizers of different sources. So that's quite interesting. And in addition to that, the corn steep liquor also fertigated quite well. So far it looks quite promising, these different sources.
Okay, here's a question. I was surprised to see the volume of water the plants were irrigated with, since most growers that I've seen tend to dry farm their Marians with maybe a watering and very dry springs. Do Marians really need as much water as you applied?
Well, actually, as I mentioned, what we applied, we were trying to minimize the amount of irrigation that we put on. So what we would do is we would monitor the water status of the plants and look at our different treatments. And if any treatment, say the weed mat plots, the plant water status started to decline relative to the other treatments, we would increase that irrigation a little bit more until we got the same water status. So basically, we were right at the edge, and if we had irrigated less, sure, our plants would have continued to grow, but I think we probably would have got less growth and less yield.
Okay, were there more pest problems or fewer pest problems in mulched rows?
Not that we're observing. And I'm saying this with a little bit of hesitation, because it's very difficult to look at these management treatment effects on disease and insect pressure in a patchwork planting like this, because obviously insects are very mobile, spores can blow, and so often it's really hard to distinguish between treatments as compared to if we were to have a solid acre of one of these particular management treatments next to another solid acre of another one. So it's not really set up to accurately compare differences in disease and insects. But with that said, really there isn't much disease pressure in this planting so far, and we have the advantage of having very dry, not just in terms of rainfall, as Dr. Bryla mentioned, but also low humidity. So we don't have a lot of cane disease, we don't have a lot of fruit disease in our blackberry production region, so we're blessed that way. And the main insects that we have, I presented on, and it was quite interesting to see a treatment effect there for cane borers. So that was quite interesting.
Okay, so what was the yield that you got in the mulched rows?
The yield in the mulched rows, well, we had the only mulch we had was weed mat, and so the yield in weed mat for 2012 was 7 ton an acre, averaged over Black Diamond and Marion, and then the weedy plots it was about 4.
Okay, great, thank you. Let's see. Was trellis height studied and its effect on moisture levels and overall yield? What trellis heights did you use?
We did not study trellis height. Our goal here was to use an industry standard. So the industry standard is about a 6-foot tall trellis for the first wire at about 6 feet, and then the second wire down from that is at about 4.5 feet, and so those wires are used to train the canes. This we do see some slightly different cane management systems throughout the industry. Some growers will use a single top wire, some use more to spread the canes out more, but the one we used is the most common. We couldn't go taller with a trellis because then we wouldn't be able to machine harvest it with the machines that we have available.
Okay. For spotted wing Drosophila, we also use Pyganic, which you didn't mention. Have you found this to be ineffective?
Yes, Pyganic is registered. We have not done research I have personally not done research comparing the two, but the spotted wing Drosophila research team that's very large here at Oregon State University and with the USDA ARS in this region, and I believe it's been confirmed in other regions, have compared the different conventional and organic products that are available for spotted wing Drosophila. And they have found that while Pyganic does do a knockdown, the populations increase or come back extremely quickly, and so it doesn't allow for a decent spray interval, making it almost ineffective commercially.
Okay. Is there any work being done on growing blackberries in high tunnels?
Yes, in our region, we're not doing research on growing in high tunnels, but we have many growers that are growing blackberries in high tunnels. The main reason for growing blackberries in high tunnels in our region, where we have the dry summers, is for sun protection, so protecting a sensitive variety like Triple Crown from sunburn damage to the fruit, and from rain protection, protecting a variety like Chester Thornless from our autumn rains when they start, so that higher marketable yields can be harvested. And finally, we do have some growers in our region that are growing early fruiting fresh varieties like Obsidian in tunnels for the same reason, to protect against rain. In other production regions in the West, like in California, most blackberries are grown in tunnels mainly to protect against disease, particularly downy mildew.
Okay. Another spotted wing Drosophila question. Is cutting down wild blackberries nearby helpful in controlling them? Do they nest there in the winter?
Yes, a cultural management recommendation for spotted wing Drosophila is to remove any potential habitat, at least that you have control over, that are around your farm. And in our region, Himalaya blackberry is a large reservoir for spotted wing Drosophila, and mainly a reservoir where populations can increase rapidly during the summer months. But it depends on the region, because there are lots of other alternative fruit crops like wild cherries, for example, that can provide a food source for SWD.
Okay. We have a question from a Florida grower. Can we grow other crops next to canes during our dormant season? What crops wouldn't interfere with blackberries, including with diseases?
My goodness, that's a difficult question for me, but I'll throw a guess out. If you grow, well, let me back up here. So blackberries, based on Dr. Valenzuela's work, we will have a pretty good handle on blackberry root growth, but something we always wonder about is whether or not growing anything between the rows might compete with blackberries, because we do know that caneberry roots do go out between the rows. That has been determined, for example, in raspberry, where a between row grass does lower the root growth in the row middle. Would it be a big deal for the blackberries? Probably not as much as in-row competition, and the plant would likely compensate. So blackberries prefer a neutral pH, so you'd have to grow a companion crop in the middles that would be have the same soil nutrient requirements as blackberry. You would want to make sure that it was a crop that could be irrigated with drip, so you didn't interfere with the canopy or the moisture in the canopy in the blackberries. And there'd be a lot of management things that would need to be considered, that where the harvest times don't overlap, or pickers could still get in the field. I don't know many growers that are, or any that are doing that type of thing, but I guess it's a possibility.
Okay. Another question, is orange felt blotch a problem in Oregon? And if so, do you know any organic control methods or inputs?
Orange felt blotch, or also known as orange cane blotch, cephaloris is that disease. It is not found in the West. I'm familiar with it because of my visits to the Southeast. It is a very important cane disease to blackberries in the Southeast. The organic controls that I've discussed with growers from the Southeast, are limited, but there's some really interesting work that Phil Brannon in Georgia has shared, and some key things that can be tried from an organic production system would be caning out very quickly, so removing the dying floricanes very quickly, which is a very good tool for any cane disease problem, including the cane diseases that we have here in the West. No overhead irrigation, also an important tool in the West for any cane disease or fruit disease. And of course, one of the reasons why any cane disease or fruit disease is more of a problem in the Southeast is because of the high humidity and rain that occurs during the fruiting season. And we don't have that, which is a real benefit to us. But one thing that Phil Brannon has shared is that any in-row weed management use of black plastic or weed mat can have real positive effects on reducing a disease like cane blotch. And I think that's a real added benefit in a production region like the Southeast, where they think it might be related to reducing the humidity around the base of the canes or increasing canopy temperature. And I know that here we are interested in the impact that weed mat has on canopy temperature, and some earlier work in SWD done by Dr. Vaughn Walton here at Oregon State University and the group that's working on SWD, they are also finding that the high canopy temperatures that are a result of using weed mat in blueberries, where it's a very common production practice here, might be reducing the fecundity or the fertility of spotted-winged Drosophila females. So if that's the case, that's a huge added production benefit to weed mat.
Okay. What outcomes might you expect in rows mulched with chips, mulch, straw, etc.? Yields and possible pest issues? I know we had a webinar on blueberry roots, which mentioned some of those things, which might be relevant. But yeah, if you could discuss that.
Well, we have not compared those in blackberries, so I don't know what difference there would be in blackberries. One of the challenges that we have in some blackberries is that if you put thick layers of any organic mulch around the plant, we can actually see a reduction in primocane growth around in the crown on a crown producing plant like a triple crown Chester or a trailing blackberry like Marion, Obsidian, or Black Diamond. It can actually reduce the number of primocanes that emerge, which would reduce yield. So that's something certainly to be cautious about. Any organic material that you put around plants or mulch in the row, we always recommend that it be tested for pH, nutrient content, anything like that. You need to know what are you putting on your farm and what impact that might have on nutrient and pH management. And then finally, straws and organic materials, you need to be concerned about the presence of any weed seeds in there. You might be aggravating weed management problems. And finally, rodents can be increased when you use mulches. And in all honesty, under our weed mat mulch, rodents are more of a problem, particularly field mice or voles. And so an advantage to a zippered system would be, and we'd like to try this or plan to try this, is you can open the weed mat of a zippered system and leave it open for a period of time, let's say in the late winter, so that the predators can get at the voles before breeding season.
Okay, and what is the best pot size to use if you have substrate management?
Yeah, I'm not gonna, if you're growing blackberries in containers, I think is the question, and so that's a bit far out from our webinar, so I think I'll decline answering
Okay.
that.
Okay. Let's see. We have time for one or two more questions. Did you fertilize throughout the season, or only twice? Once before and once after the harvest?
Um, we we fertigated during the second and third years, and we divided the total nitrogen applied, and we used fish in the fertigation system into about 4 equal portions, and fertigated from, depended on the year, but from April into early June-ish. So we harvest in July, so there's no fertilizer applied anytime during harvest or after harvest.
Okay, and we had a comment that with climate change, we're seeing more summer rains than we used to and can't rely on dry weather anymore. I don't know if you've observed that in Oregon.
Yeah, certainly the concerns about climate change and the impact that has on not just summer weather, but winter weather is something many of us are concerned about, and it requires further research to see what impact that might have.
Okay, well, we are running out of time, but I'd like to thank everyone for your questions and mention once again that you can find this and many other upcoming and archived webinars on our organic farming and research topics at the link on your screen. And we would very much appreciate if you could fill out the evaluation survey that you'll be receiving in an email later today. So we'd like to thank you so much, Bernadine, David, and Louise, for giving this presentation today. And thanks to everyone for joining us.